This is a walking talking mock for Chemistry Unit 1. It's the higher paper from June 2015. The total mark for the paper is 60 and you are allowed 1 hour, which roughly means that there is 1 mark available for every minute. Okay, so question 1. This question is about atomic structure and elements. Copy and complete the sentences. Question 1A1. The atomic number of an atom is the number of protons that the atom contains. That's 1 mark. The mass number of an atom is the number of protons and neutrons. Number of protons and neutrons that the nucleus contains. Question 1B. Explain why an atom has no overall charge. Use the relative electrical charges of subatomic particles in your explanation. Okay, so let's look at what the question wants. It wants us to use the relative electrical charges. Alright, so then we've got to think about our subatomic particles. The proton is +1, the neutron is neutral, and the electron is -1. Okay, so you would start by saying that the relative electrical charges are -1 for an electron and +1 for the proton. The second mark would come from saying that the number of electrons is equal to the number of protons. So including that bit in would then get you the second mark for this question. If we then move on to question 1C, we have to explain why fluorine and chlorine are in the same group of the periodic table. Give the electronic structures of fluorine and chlorine in your explanation. Okay, so look at what the question is asking you. Explain why they're in the same group of the periodic table. And use the electronic structures in your explanation. So if you find your periodic table, you'll see that they are both in group 7. And the group that an element belongs to tells you how many electrons are in its outer shell. So a group 7 element has got 7 electrons in its outer shell. So if you wrote that, that will get you 1 mark. The second mark comes from giving the electronic structures of fluorine and chlorine in your explanation. Now, for this mark, you can either write it as in 2A8 formation, or you can draw the electron structure in shells. So both of these methods will give you 1 mark. Then what you need to do is go and find fluorine and chlorine in your periodic table. From the periodic table, we're looking for the proton number or atomic number, and that will tell us the number of electrons. So if you find fluorine, you will see that there are 9 electrons. So fluorine structure would be 2 and then 7. And then if you wanted to do that on your diagram, you would then do 2 in the first shell, then 1, 2, 3, 4, 5, 6, 7 in the outer shell. And that will give you fluorine. Then we've got to find chlorine. Chlorine has got 17 electrons, so its structure will be 2, 8, 7. Okay, and then if we were to draw chlorine, we'd have 2 on the inner shell, then 8 on the second one, and then again we have 7 in its outer shell. So overall that will give you 2 marks for this answer. Say about them being in group 7 and what group 7 has, 7 electrons in the outer shell, and then remember to give the structures. Okay, so always double check the question at the end to make sure that you've answered every single bit and not just the first part. Moving on to question 1D. Figure 1 shows the electronic structure of an atom of a non-metal. We've got the nucleus that's been labelled, and then we have its electronic structure. So, it wants you to identify the chemical symbol of this element. So the first thing you are going to do is add up all of the electrons. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 and 16. So I've got 16 electrons, which means that I've got 16 protons. So what you're looking for is an atomic number or a proton number of 16. So at this point what you need to do is reference your periodic table. Find the element whose bottom number is 16 or atomic number is 16. And from the periodic table you should see that this is sulfur. So then, because you know that that's sulfur, you should then give this box a big tick. The next question says, when elements react, their atoms join with other atoms to form compounds. Complete the sentence. Compounds formed when non-metals react with metals consist of particles called. Now, what they're wanting you to write for this one is ions. Okay, and you will know that from looking at the information you've got, non-metals and metals. Now, metals will always lose electrons to become positive, and non-metals will gain electrons to become negative. And then what you've got there is the electrostatic force of attraction holding them in place. Okay, and the way that that loses an electron is that it gives it to the non-metal. So compounds formed when non-metals react with metals consist of particles called ions, because this is an example of ionic bonding. Okay, now the next one. Compounds formed from only non-metals consist of particles called. Now this is a tricky one because you'll be wanting to write covalent bonding. However, it's asking what the particles are called. Okay, so imagine you've got two non-metals joined together. They don't make an atom, they make a molecule. So the answer is molecule. And on to question 2. Limestone is used to make many different materials. Heating limestone produces calcium oxide and carbon dioxide. Complete the sentences. The main compound in limestone is calcium carbonate for this one. Okay, question 2A2. The reaction to produce calcium oxide from limestone is thermal decomposition. Remembering that thermal refers to heat and decomposition refers to breaking down. So limestone breaks down with heat to form calcium oxide. Question 2A3. Calcium hydroxide is produced when calcium oxide reacts with water. Okay, so if you see hydroxide, it usually means that there's going to be a reaction with water somewhere. Right, question 2A4. Calcium hydroxide is used to neutralize acids because it's an alkali. Okay, question 2b. Cement is made from limestone and clay. Concrete is made by mixing cement with water, sand and aggregate, which is small pieces of rock. A group of students did an investigation on the amount of aggregate needed to make the strongest concrete beam. The student used this method, used the same mass of cement and the same mass of sand, but changed the mass of aggregate to make 7 different concrete mixtures. Use the different concrete mixtures to make beams of the same size. Add weights, as shown in figure 2, until the concrete beam breaks. Okay, so here we've got our diagram. We have weights, concrete beam rested on a block. Right, so the student did the practical and he collected his results and he plotted them on the graph. So we have got on the x-axis the mass of aggregate in grams. And then we've got on the y-axis the force to break the concrete beam in newtons. Okay, now this one, because it's on the x-axis, is the independent variable, the one that we change in our investigation. And then this one on the y-axis is the dependent variable, or the one that we measure in our investigation. Okay, now the question about the graph refers to there being one anomalous point, and it asks you to draw 2 straight lines of best fit in order to find the anomaly, which is quite unusual in science because we never normally really asked to draw 2 lines of best fit. Right, so what we're going to do then is we're going to try and look at this as if we've got like half a graph. Now, the first mark is for putting a straight line through the first, which is that one, the second, and the 4th point. So your first line of best fit, obviously you need to do it with a ruler, will look like that. The second mark is for doing a straight line through the last 4 points. So that would be these ones here, 1, 2, 3, 4. Okay, so drawing that those 2 lines of best fit would have got us the 2 marks for this question. Question 2b2. Describe one way the student could improve the method so that their results are more accurate for each graph point. Right, so what we're looking at here is the accuracy of the graph point. So how do we know that that point of the graph should be there? Now what you've got to do for this one is you've got to say that that student needs to repeat the experiment for each mass, so essentially doing it 3 times like we always do experiments. So 1 mark for saying repeat the experiment at each mass of aggregate. Right, and then the second point is what you're going to do with that data. So normally in lesson we do 3 repeats and then we calculate a mean or an average value for each mass. And the average value is the one that we plot. So your second mark is going to be from saying use your results to calculate the average value. Okay, the next part of this question requires you to read the graph and show what the graph, and say what the graph is showing. So question 2b3, what force is needed to break a concrete beam containing no aggregate? Well, if you remember, the graph looks like this. We drew 2 lines of best fit like that. 0 aggregate will be there, so what you'll need to do is draw your line, extend it so it crosses the y-axis, and then that will be the point that you write down. And from this graph, it should be around 35. But they do give you a limit. So this question's giving you a limit between about 34 and 40. But you must make sure that you do your working out on the graph. Okay, now this question, it also wants you to use information from the graph. One of the students concluded that the force needed to break a concrete beam increases as the mass of aggregate increases. The student's conclusion was not completely correct. Use values from the graph to explain why. Now, thinking about the graph again, so we've got now 2 lines looking something like that. So the student is kind of correct, but only for the first part of the graph. So what you will need to say is, at first, the force needed to break the beam increases. That's 1 mark. The second bit is for saying about what happens on the second part of the graph. So what you've got to say then is the force then starts to decrease as more aggregate is added. And the third mark is going to be from saying at which point that starts changing. So it's going to be the peak of the graph, or at least where they cross. And from your graph, if you skip the video back a bit, you'll be able to see that that is around 400 grams. So your third mark is for saying that's where the point changes. All these things are really, really easy to see from the graph. You must make sure that you write them down. If we're looking for 3 marks, we want 3 things from that graph. So first bit of the graph, second bit of the graph, and then where it all starts to change. Moving on to question 3. This question is about life, the Earth and its atmosphere. 3a. There are many theories about how life was formed on Earth. Suggest reason why there are many theories. Okay, so there's a couple of things you could put for this, but you're only going to get 1 mark. You need to say either that there's not enough evidence or proof, or that because it was billions of years ago, there was no one around to witness it. Okay, and the next question is one of those that everybody hates. It's a 6 marker. So in the question you will be assessed on using good English, organising information clearly, using specialist terms where appropriate. The Earth and its atmosphere today are not like the early Earth and its atmosphere. So we've got here the early Earth, and it's covered by volcanoes. Most of the atmosphere was carbon dioxide and water vapour. Then we've got the Earth today. Most of the surface is covered by oceans. Most of the atmosphere is nitrogen and oxygen. If we look at the question, it says describe and explain how the surface of the early Earth and its atmosphere have changed to form the surface of the Earth and its atmosphere today. Okay, so I'm not going to do the whole answer for this, but I'm just going to do a quick plan of how we might want to include the points. And what I like to do is I like to use something called a fishbone organizer. So this is the body, this is its tail, this is its head, and then it's got 6 bones that are for the 6 points that are within the question. Okay? Right, so what I'm wanting to think about is how the surface of the early Earth and atmosphere have changed. So we're thinking about the atmosphere. Now, one thing that happened was the oxygen levels increased because plants started to evolve. They took in the carbon dioxide and gave out oxygen. So in an exam, if I was planning this, I would have drawn this quite small in the margin, And for my first point, to remind me that I need to write about it, I would have put green plants to remind me that green plants evolved, and then CO2 to O2, show that photosynthesis is the process that turns CO2 into O2. Okay, the next point is to do with carbon dioxide and its ability to dissolve within water. So what happened when the oceans formed is that carbon dioxide dissolved within the oceans and became locked up there. Okay, so we've got second point, oceans form, CO2 dissolves in there. There's also one other thing called lockup for carbon dioxide, and it's in the formation of sedimentary or carbonate rocks. Right, so that's a little bit of description about this how this process happened. What we need to do now is put a little bit of explanation in there. So, the oceans formed because the earth cooled and therefore the water vapour condensed into liquid water. You also need to give a little bit of information about the volcanoes. So we're going to say the number of volcanoes reduced because the earth cooled, forming the crust. And then the last point is going to be about the nitrogen. Now, this is always quite a complicated one. So if you try and learn like one sentence and remember that one sentence, then that's what you need to write down about nitrogen in the atmosphere. And it's going to be nitrogen formed because ammonia in the Earth's early atmosphere reacted with oxygen. You can also put that it's because of denitrifying bacteria. Right, so then quick overview to make sure we've got everything in that we want to include. So we've got green plants evolved and started carrying out photosynthesis, which turns CO2 into O2. The oceans formed and the carbon dioxide was removed because it dissolved into the oceans. The carbon dioxide can also become locked up in carbonate rocks. The formation of the oceans happened because Earth cooled and the water vapour condensed to form liquid water. The number of volcanoes reduced because the Earth cooled and so the crust formed. And then last point, the ammonia reacts with oxygen to form nitrogen. And then you've also got that the evolution of denitrifying bacteria also adds to the increase of nitrogen in the atmosphere. Okay, so that's a rough plan of the points that I want to include. The head of the fish is going to be an introduction, and the tail is going to be a conclusion. Now, don't spend ages trying to think about this. You make sure you get your science points in. The introduction only needs to be one sentence, and it's normally just a rephrase of the question. Then the conclusion is just a really quick summary at the end. If you can't think of an introduction and a conclusion, just leave it. As long as you've got these points written down, you will get the marks. Okay? Question 4. This question is about metals. Figure 4 shows the metals used to make pylons and wires of overhead cables. So we've got the pylon there is made out of steel and the wires of aluminium. An ore contains a metal compound. A metal is extracted from its ore in 3 main stages, as shown in figure 5. Stage 1, mining to get the ore. The ore is separated to get the metal compound, and then extraction process removes the metal, so we end up getting it on its own. The question says, explain why stage 2 needs to be done. Okay, so this needs to be done because an ore is not pure. It contains impurities and it does not contain 100% of the metal compound. So we need to remove that rock or the other compound before we start extracting it. So 2 marks there, 1 mark for saying it's not pure and another mark for saying that the impurities or the other compounds need to be removed. Okay, so there are 2 marks. What I would say is just try and explain everything you write down. So don't just write a couple of words. Try and put a little bit of evidence behind it to back it up, and it'll let you get the more marks then. Don't leave any question empty. Just write something down, anything that you can remember about it, because you've got more chance then of getting a mark if there's something written, whereas if there's nothing there, you're definitely not getting anything. Question 4b. Cast iron from a blast furnace contains 96% iron and 4% carbon. Cast iron is not suitable for the manufacture of pylons. Give one reason why. Now, the reason for this is it's brittle. Okay, so don't say it's weak, you need to say it's brittle. Right, the next question requires you to have a look at this diagram and then try and work out what is going on inside the furnace. So look at what's being added. Cast iron and oxygen. And then look what comes out. Steel and waste gases. Now it also requires you to have a little bit of knowledge about steel. Steel is also an alloy, but it contains a lower percentage of carbon. So we've got to be able to remove the carbon somehow. And what happens is the oxygen reacts with some of the carbon in the cast iron, and oxygen and carbon, when they react together, they will produce CO2. And the second mark here is going to be for saying that this reduces the percentage of carbon in the mixture. Okay, so this reduces the percentage of carbon to produce the steel. Question 4c. Aluminium and copper are good conductors of electricity. State one property that makes aluminium more suitable than copper for overhead cables. Okay, so one thing about aluminium compared to copper is that aluminium has a lower density, which basically means that it's not as heavy, because you don't want a really heavy metal being used to make overhead power cables, because they might snap and break under the weight. Question 4c2. How can you tell that copper is a transition metal and aluminium is not a transition metal from the position of each metal in the periodic table? 2 marks. Right, so you're going to get 1 mark from saying where copper is, and copper is in that central or middle block of the periodic table. And then if you remember, this is where the transition metals are found, in that central or middle block. Then we find aluminium. Aluminium is in group 3 of the periodic table, so therefore it is not a transition metal. Question 4c3. Copper can be extracted from solutions of copper salts by adding iron. Explain why. Now this one is a reactivity series question, but it's a little bit hidden. So you need to look for copper and iron in the reactivity series. There's 2 marks here. One for saying that iron is more reactive than copper, and the second one is for saying that the copper is displaced. So remembering that a more reactive metal will displace a less reactive metal from its salt. Question 5. Crude oil is a fossil fuel. Describe how crude oil is separated into fractions. Now there's loads of stuff you can write here. but you get 1 mark for each point you put, so you're looking for at least 4 points to get you 4 marks. So I will bullet point the things that the marks are available for. So the first one is going to be for saying the crude oil is heated. Another mark could be for saying that the heating will evaporate the substances or the hydrocarbons in the crude oil. The next mark could be for saying that the fractionating column is hotter at the bottom and is cooler at the top. So the temperature varies as you go up the column. The next point will be for saying that different fractions have different boiling points based on the chain length that it contains. If you've got some long chain molecules, then they will have lots of intermolecular forces between them, which means that they require a lot of energy to break, so they will have a high boiling point. If you use shorter chain, you have a few intermolecular forces, which don't really need a lot of heat to break, so they will have a low boiling point, and they will be the ones that travel the furthest or travel the way to the top. Now, because different fractions have got different boiling points, it means that they will condense at different points in the tower. Okay, so that answer gives a really full description. Okay, so that will get you definitely the 4 marks. If you only manage to get 4 of those points, however, then you still get the 4 marks. But it's good to try and impress the examiner. They're more likely to give you a mark that they're hesitant on in a different area. Question 5b. Fuel oil is one of the fractions in crude oil. Power stations burn oil to generate electricity. The waste gases from the combustion of fuel oil contain carbon dioxide, water vapour, sulfur dioxide and oxides of nitrogen. The waste gases are passed through a suspension of limestone in water. Limestone is mainly calcium carbonate. Suggest how the use of a suspension of limestone decreases one of the environmental impacts that the waste gases will cause. Okay, so there's 2 choices here really, and I'll go through both of them just so you know. The first environmental impact is acid rain. Okay, now acid rain is caused by sulfur dioxides or oxides of nitrogen, and the limestone or the calcium carbonate can help with that because it can neutralise it. So that one would give you your 3 marks there. Acid rain caused by sulfur dioxide or oxides of nitrogen, react with limestone and neutralised. There is, however, if you can't think of that one, a different one that you could have. And the other one is global warming. Now, the global warming is caused by the carbon dioxide because carbon dioxide is a greenhouse gas. Now, when carbon dioxide is passed through the limestone, what will happen is the carbon dioxide will dissolve then in the suspension of the limestone, and it will become locked up within the limestone. Okay, so it doesn't matter which one you choose. Just choose the one that you feel most confident about explaining, and then that will make sure that you are bagging your 3 marks. Question 5c. Some fractions from crude oil contain large hydrocarbon molecules. Hydrocarbon molecules such as decane can be cracked to produce smaller, more useful molecules. Write the correct formula of the third product to complete the chemical equation. You do not need to give the name of this product. Right, what's key here is the carbons. So I've got 10 to start with, I've got 5 there, and I've got 3 there, which is 8. So that leaves me with 2 that are missing, so it's going to be C2. I'm going to do the same with the hydrogens. I've got 22, and I've got 10, and I've got 8, which is 18, which leaves me with 4 hydrogens missing. So C2H4. The next bit of the question is about smart polymers. So some polymers are described as smart polymers. Suggest one property of a smart polymer that is different to that of an ordinary polymer. Now, a good one to go for with smart polymers is they've got a shape memory, which means that they can return to their original shape. Right, so we're on to question 6, which is the last question of this exam. Useful materials including foods and fuels are produced from plants. Some plants have seeds that contain vegetable oils. Give one reason why vegetable oils are important foods and fuels. Okay, so this is just a saying that the vegetable oils provide energy. Question 6A2. State the 2 main stages used to extract a sample of vegetable oil from seeds. Okay, so for this one, you would need to, you need to pick 2 out of 3. Now, they are crushing, pressing, and distillation. And because the question says state, it means that we don't need to say what these things mean. Question 6b. One property of a vegetable oil gives the oil an advantage over water for cooking foods. Explain how. Right, so this is for saying that the vegetable oils have a higher boiling point than water, which allows the food to be cooked at a higher temperature than water. So the foods are cooked faster. So the one property is they've got a higher boiling point, and explain how. So it cooks the food faster. And this is really what they were looking for. There is no mark for going off on a tangent speaking about texture or flavour. It just wants to know about the boiling points for this question. And finally, we've reached the last question. Vegetable oils and water do not mix. An emulsion is made by shaking a vegetable oil and water with an emulsifier, as shown in figure 7. Explain how the emulsifier molecules are able to produce an emulsion that is a stable mixture containing the vegetable oil and water. Use the diagram of the emulsifier molecule to help you answer this question. Okay, so they've been really good here because they've given you the molecule. So what we will do is we will draw it out. So I'm going to do the head of the emulsifier and then the tail of the emulsifier. Right, there's some key words here that we need to remember. The head of the molecule is hydrophilic, and that means that it likes the water or it's attracted to the water. The tail is called hydrophobic tail. Now the hydrophobic tail does not like water. Okay, so it is attracted to the oil. Now what happens is that the head of the molecule will hold on to the water, and the tail of the molecule will hold on to the oil, and it will stop them from separating. So what it actually then produces is a stable suspension of the droplets of oil. Okay, and you definitely need to say that hydrophilic is the head and hydrophobic is the tail of the molecule. And there you go, that brings us to the end of this walking talking mock for C1. Good luck, try your best, and remember, do not leave any question blank. Please just make an educated statement, just write anything you know about that topic. Good luck.